right, in this lesson, 6.3, we're going to deal with binomial radicals. So we'll continue with the different roots that we've been working with, third root, fourth root, fifth root. But we're going to have binomials that we're either going to add, subtract, multiply. Okay, we had some technical difficulties. Hopefully this is right on. So what we have in example 1 is essentially 10x minus x, which would be 9x. But here it's 10 root 3 minus root 3. That's like 10 root 3 minus 1 root 3. So it's just 9 root 3. Can't simplify square root of 3 at all, so we move on. Example 2. This is what some of you do on a test. Some of you, hopefully nobody that's watching, are going to add the 128 and the 250 and get the square root of 378. That is totally wrong. You know, if I ask you to do the square root of 4 plus the square root of 9, that's not the square root of 13. You can't just add the roots. Okay, the square root of 4 plus square root of 9 is 2 plus 3. That's 5, and the square root of 13 is not 5. So what you need to do on these problems here is simplify them first and see if you can get the roots to be identical. You can either use the prime factorization or you could use your sheet. These are bigger numbers. I guess I'd kind of like to use my sheet here. So while I would use my sheet, I would have, I put the 4 in the wrong spot, excuse me. The 4 down here, I got third root. What's a big power of 3 that goes into 128? Well, 64 goes in there twice. And that allows me to change my first term into 4 times, what's the third root of 64? 4 times the third root of 2. So the first term is really 16 third root of 2. And these are usually going to be set up in a way where you can put the two terms together. So that tells me that I'm probably going to have a third root of 2 when I simplify this. So that tells me I'm going to try 250 divided by 2 and see if that works. And 252 divided by 2 is 125. And that's on my list. That's the biggest power of 3 that goes into 250. So it's going to work out nice. What do I mean by that? Well, I'm going to have 8. Third root of 125 is 5. That's third root of 2. 8 times 5 is 40. The third root of 2. And then now I've essentially got 16x plus 40x. So I can put the numbers in front together and just leave the root part of it. Okay, so make sure your root part is identical. Not only in the index, not only in the little number up here, but also on the inside when you're adding and subtracting. It doesn't have to be when you're multiplying and dividing, but adding and subtracting it does. Example 3, I'm looking at the root part. Both roots have an index of 4 and a 5 on the inside, so I can put them together. I just put these outsides together. What's 2x plus 9x? 11x. And then I leave the root part. Easy peasy. Can't believe I just said that. I guess I can. Example 4. Here it looks good. I got 5xy on both of them on the inside, but upon further review, got out the magnifying glass and see there's a 5 here and a 7 here. So the roots are different. So this one's already simplified. You can't go anymore on this one. If I asked you to simplify this one, you'd say yes, meaning that it's done. It's already simplified. Right, so that's the basics of adding. Binomials would have been the same thing if it was subtracting. I have subtracting one example 1. So that's adding and subtracting. What about if you multiply? What if we do some FOILing? Oh, we've done that before. Just going to FOIL it out. Get 3 root 5. 3 times negative root 3 is negative 3 root 3. Negative 2 root 5 times root 5. Careful here. That's negative 2 times 5, or negative 10. You know, if you did that in your head, got negative 20, or negative 10, I mean, very good. 5 times 5 is 25, square root of that's 5, so this is going to turn into 2 times 5, 10. And then the last term is negative times a negative positive. 2, and then 5 times 3 is 15. So you got root 15. So we're going to look to add like terms and then do the simplifying. I already did the simplifying. I made negative 2 times 5 equal to 10. And other than that, there aren't any like roots. I got root 15, I got root 3, and I got root 5. They're all different, so this is simplified. Example 6 I have over to the right on this one. 2 root 3 minus root 7 squared. That follows our squared ants situation. First one squared, twice the product, last one squared. You could write it twice and FOIL it out, but I really want you to get in the habit of doing first one squared plus twice the product, and the product would be 2 root 3 times negative root 7. See how I use the negative right there? And you got the last one squared. Slide that over a little bit. Running out of room. So then I got plus negative root 7 squared. First one squared, twice the product, last one squared. The first one squared would be 4 times 3, 12. 2 squared is 4, square root 3 squared is 3. Multiplying the next one, I would have 2 times 2 is 4. 4 times negative is negative 4. And on the inside, I'd have 3 times 7, 21. And the last one, I have a negative squared, so positive. And square root 7 times square root 7 is 7. So 12 minus 4, root 21 plus 7. Add like terms, I get 19 minus 4, root 21. Example 7. What are these expressions called when you have the same binomial except for the sign in the middle is different? So you're getting it down, they're called conjugates. When you multiply conjugates, what beautiful thing happens? Middles cancel out. 3 times 3 is 9. Square root 7 times square root 7 is 7. And it's minus. Get positive times a negative. So the answer to that one is 2. Okay, what are you going to do if you end up rationalizing the denominator, meaning you can't have a square root in the denominator? We did this with the i's. If you remember, you might have had a problem like 2 over 3 plus I. We said, how do you get rid of I in the denominator last semester? And we learned that we'd take top and bottom times the conjugate 3 minus I. Well, the same thing applies here. You've got a binomial, so we're going to use the conjugate. The conjugate of 3 root 5 minus 1 is 3 root 5 plus 1. And now we just have some serious FOILing to do on top, and we've got conjugates on the bottom. On the top, I've got 12 root 5. I've got plus 4. And I've got 2 root 3 times 3 root 5. So that'd be 2 times 3, 6. 3 times 5 on the inside, square root 15. And then finally I have 2 root 3 times 1, which would just be 2 root 3. Looking to add like terms, I don't have any like terms, so I don't have to do any more in the numerator there. The denominator would turn into 3 root 5 times 3 root 5, which is 9 times regular 5, 45. 3 root 5 squared, 3 squared, 9, square root 5 squared, 5. 9 times 5, 45. And then you'd have negative 1 plus 1 is minus 1. So I'd have 12 root 5 plus 4 plus 6 root 15. You can put these top ones in any order over 44. That's a pretty good answer. It's just not an exceptional answer, an awesome answer, because if you look closely, every term up here is even. So you could take a 2 out of every single term. It'd be 6 root 5. Instead of 4, you'd have 2. Instead of 6 root 15, you'd have 3 root 15. Here you'd have root 3. And finally, you'd have 22. more here in practice. There's a difference with this one though. The difference is there's some simplifying to be done. You should change the square root of 18 into 3 root 2. And the square root of 50 into 5 root 2. So on the top, you've actually got 6 root 2 minus 5 root 2. The top actually simplifies to root 2. Okay. So by simplifying that, I made it considerably easier to deal with. The number became smaller. I have a monomial instead of a binomial. And now I just take top and bottom times the conjugate, otherwise known as the evil twin. And you get 6 root 2 minus 3 root 14. I distribute that. On the bottom, you'll have 6 times 6, 36, minus 9 times 7, 63. 3 times 3, 9. Square root 7 times square root 7, 7. 9 times 7, 63. Subtract those, you get negative 27. And if you look, you should be saying, uh-oh, same thing on this one. They are all divisible by 3. In fact, if you were to look in your back of the book on this type of problem, they would never have a negative on the bottom. So what they would do is actually take out a negative 3. So if you took out a negative 3, it would look like this. Square root 14. So if I took a negative 3 out of that. Minus 2 root 2. That's if I took a negative 3 out of that. 6 divided by negative 3 is negative 2. All over 9. If you had all the signs switched, where you had negative root 14, positive 2 root 2, and negative 9, that's a correct answer. It's just not what you're going to see in the back of the book. And it looks like that ends our lesson for this time here. Thanks for watching. Have a great day.